More titled Inscribed Angles and Polygons for Integrated 3 today. How about a volunteer to run my essential question today? What are we trying to answer? Who's got it for me?
How are inscribed angles related to their intercepted arcs? How are the angles of an inscribed quadrilateral related to each other?
It's kind of a tongue twister of a question today, isn't it? Okay. No, I don't think that. I think you're very smart. I said, so inscribed angles, we got to talk about that, and intercepted arcs. How are angles of inscribed quadrilaterals related to each other? We'll talk about that. So some pretty simple goals today, guys. We're going to look at using inscribed angles, and we're going to look at inscribed polygons. Okay? Inscribed angle. Volunteer to read that for me. What, Eli? Inscribed angle?
An inscribed angle is an angle whose vertex is on a circle and whose sides contain.
Okay, so if I have a circle like this is what an inscribed angle is, kids. It's an angle, not at the center of the circle anymore, but the vertex is actually where? Yeah, and then the two sides of the angle are chords to the circle. So that would be an inscribed angle. That's what we're talking about right there, okay? Next one then says, what's an intercepted arc?
An arc that lies between two lines, rays, or segments is called an intercepted arc.
So if you take the above example right up there, if you took the above example where I had an angle right here, this part right here, this part right here, would be your intercepted arc. Okay? That's the arc that gets intercepted. Okay, sub 10. This is kind of a big one. It says if the endpoints of a chord or arc lie in the sides of an inscribed angle, then the chord or the arc is said to
Subtend the angle.
Okay, so if the endpoints of a chord or arc lie on the sides of an inscribed angle, here and here, then the chord or arc is said to subtend the angle, okay?
You can't use the word in its own definition.
This chord and this arc subtend this angle. That's what that really means, okay? Inscribed polygon says what, kids?
Polygon with all vertices on the circle.
Polygon with all vertices on a circle. Somebody read circumscribed circle for me.
A circle that contains all the vertices of an inscribed polygon.
I'm going to tell you right now, kids, these two things right here, they mean exactly the same thing. If I have a polygon, maybe I have, I don't know, maybe I have a hexagon. I'll do my best.
I hate my circles.
Really?
God, you're so ugly.
I'm sorry, Keegan.
I need to use that thingy.
I know, this is the only thing that saves me because you know what? If I had to do it the way you guys are doing it, I'm pretty sure I'd be throwing a tantrum as well. Okay, and you know what? If you want to put a triangle in there or whatever, basically, circumscribed circle, or inscribed polygon just means a polygon inside of a what?
Circle.
Inside of a circle. And if that polygon is inside the circle, aren't all the angles or all the vertices right on the circle then?
Yes.
Okay, so we've got a bunch of inscribed angles there in this when we have an inscribed polygon. That's what's going on there. Okay? All right, so terms up there. You understand what's going on?
Yes.
We're not talking about an angle at the center of the circle anymore, but we're talking about an angle being where?
In the circle.
Right on the side of the circle there, right on that, okay? We call it an inscribed angle. Okay, next page. Let's see what this says here.
Core concept.
I love this stuff here. There's some theorems and core concepts up here, right?
Yep.
Core concept, kind of hard to see. I would say take a look at your paper and say what is there. Basically, everything we talked about in the vocabulary is right here. It says an inscribed angle is an angle whose vertex is a circle and whose sides contain chords of the circle. An arc that lies between the two lines, rays, or segments is called what? It says if the endpoints of a chord or arc on the side of the inscribed circle, then the chord or arc is said to do what? Subtend the angle. Check this out. Here's a good drawing up here. I like this. Okay. What's my angle that's inscribed here? Angle what?
ABC.
Okay, and really I could call it angle B if I wanted to, couldn't I? So angle B intercepts which arc? Which arc? A to C, arc AC. All right, B intercepts arc AC. And then it says AC, arc AC does what? Subtends angle B. These two things mean exactly the kind of converses of each other. I would say segment AC subtends what? See this segment right here? A to C. This here is found by the endpoints of the two angles that intercept my arc right there. Okay? So, theorem. First theorem, kids. Here it is. This is a really important one. You ready? I would say put a star here because this is very important. It says the measure of an intercepted angle is what?
Is 1/2 the measure of its intercepted arc.
Okay, so what this is saying is this. You have an arc right here. A to what, kids? A to, not C, but A to B. It's intercepted by angle what? D, okay? What this is really saying is the measure of angle D is half the measure of what?
RKB.
So if angle D is, let me write this up here like this. If angle D is X degrees like this, kids, then the arc is how many times bigger than that? Okay, so if this was 40 degrees right here, how many degrees of an arc would you have out here, according to this theorem? 80. Okay. Now, I'm not going to get into why that's there. We'll talk about an exploration that shows some things here probably tomorrow, but here we go with this. Example 1, finding indicated measures. Using what, kids?
Inscribed arc.
All right, here we go. It says I have angle E right here. Angle DEG is how many degrees, kids? 40. All right. What do I have to find first over here?
Arc DG.
I'm looking for an arc DG. All right, where are my Dysart kids?
Right here.
You would appreciate arc DG, wouldn't you? Okay.
Dollar General.
Yeah. Or Dollar General, yeah, that's true. Okay. That's the arc I'm looking for, kids. Does that arc subtend
Yeah.
to an inscribed angle at all? Which angle does it subtend to?
EEG.
Okay, and that angle is how many degrees, kids?
40.
So if this is 40 degrees, what's that make that arc up here? Yep, the arc is twice the inscribed angle. So this is how many degrees? I'm sorry, what was that number again? 80, you said?
Yep.
Everybody understand? Give me a show of hands. How many agree with that right there? Okay, how many think they can find angle G up here?
29.
How much?
29.
Why 29, Grace?
Because I took half of 58.
Okay, so right down here you've got an arc that is how many degrees?
58.
And that arc subtends which angle up here?
G.
And that angle, that arc EF subtends should be half of 58 degrees. So that makes us how many degrees up here, kids?
29.
Awesome.
No.
What do you guys think so far?
Pretty darn easy.
I want to show you why this half comes about here a little bit. The best explanation I can give you is this. Don't draw this. I'm going to draw, so I got a triangle here. You guys okay with my triangle? You guys like my triangle?
Yeah.
I'm going to try and inscribe a triangle in there. You ready? Lie to me and say yes.
Yes.
Yes, sir.
That's what Brianna said.
What Brianna say?
Brianna has access. No, my server's already down.
Your server is down?
What?
You said your server is down?
Servers are really bad.
Oh. Kids, let's just talk about this. Why? Do you agree that this angle right here is an inscribed angle? And this is an inscribed angle?
Yes.
Take a look at what I've highlighted in green. What shape forms when I put those inscribed angles together?
Triangle.
Triangle, right? Well, think about this, kids. Think about this. How many degrees are in a triangle? We're throwing that triangle some 180 degrees inscribed in a circle. How many degrees are there in a circle?
360.
How does 180 relate to 360?
Half.
Do you understand why these inscribed angles are half of the arc measures that they intercept?
Yeah.
Or you understand why the arc measures are twice as much the inscribed angle that they subtend to?
Yup.
Are you okay with this?
Yes.
All right? That's the best example I can give you as to why that theorem works. Triangles inscribed in circles add up to 180 degrees, and in that arc measures of all of those intercepted arcs would add up to 360, being half of what value? Or twice of what value? I'm sorry. 180. Very good. So forget that page. Let's go back to what we were working on. Let's jump down to example 2. Oh my gosh, next page, I guess, right?
Yeah.
So right up here, kids, I want you to try this on your own. See what you come up with. It says, find the measure of arc. Now, we've got to be careful on this. H to what to M? H to M to what? L. And H to J to L. What do you notice about H, J, L, and L, K, H? See what you come up with there. I'm curious. We got to find a measure of arc. What? Ooh, I don't want that. I'm going to write these down. What's the first one we have to find, kids?
HML.
Hate my life.
Oh, come on. I was going to call it heavy metal love. That was a good one, wasn't it? Whoa.
Heavy jazz lug.
Okay.
Lug.
Jeepers. Keegan, you weren't supposed to say that. Oh, we are supposed to find an angle here. Oh, shoot. We're supposed to find an angle here, not an arc, right?
I didn't see that. Ugh.
Okay. Anybody have a measure for arc HML yet?
218.
Where are you getting 218 from?
Because angle K is 109.
Oh, I thought you were going north to Waterloo. That's how I thought you got 218.
Nope, I just
Oh.
doubled 109.
Let's just highlight HML, kids. HML starts here. We have to go clockwise because we got to pass through M to get to what, kids? Okay. That arc right there, what arc does that subtend to? Which angle, I should say, does that arc
K.
subtend to?
K.
Angle K down here. And angle K really is how many degrees?
109.
So if this is 109, then we have to double that to get,
218.
I agree, 218 degrees. Now, it said take a look at an angle. What was the angle measure we had to look at? H to J to what?
L.
Oh my gosh, kids. HJL, doesn't that angle basically intercept that arc, HML also? Isn't that crazy?
Wait, what?
Well, this angle that I didn't highlight down here, doesn't that intercept the arc in green?
Yeah.
But doesn't angle J also do the same thing, intercept the arc in green again?
So would it also be
So if this is 109 degrees, and we know that this arc measures how much?
The other one's 109.
This one must be 109 degrees also. Okay, so what, HJL, Sonny, did I leave notes there for you, kiddo? This should be 109 degrees. So the question becomes, what do you notice about HJL in yellow?
They're the same.
And let's highlight LKH in red.
Lazy Keegan Howell.
Ah! I like that one. I was going to say love Keegan Howell, though. Day's not complete unless Keegan's in the classroom. What do you notice about the two angles, red and yellow?
They're the same.
They are the same. What do you notice? We notice that, they are the same. Because those two angles intercept the same arc, don't they?
Yeah, they do.
Okay, pretty cool?
Pretty cool.
Again, really all this is, either you multiply by 2 or you divide by 2. Study, that's what we're working on. Multiply by 2 and dividing by 2. We're going back to elementary days, okay?
You
Yeah.
understand? Yep, sure. Not quite.
I think you'll pick up on the rest. If you don't get it. Okay. All right, let's move on. Okay, another theorem. This is pretty important. And we kind of just talked about it already. We set up this next theorem. The next theorem is called Inscribed Angles of a Circle theorem. How about a volunteer to read my definition?
If two inscribed angles of a circle intercept the same arc, then the angles are congruent.
Isn't that what happened up here? Didn't the yellow angle and the red angle intercept the same green arc up here?
Yes.
So right down here, looks like they want angle D and angle C to be what?
The same.
What does angle D intercept here, kids?
A,
What does angle C intercept here.
AB.
If those two angles intercept the same arc, then what must be true about those two angles? They have to be the same measure. That's exactly what we just explored right up here. What we just talked about right up here is this theorem in words. Okay? So let's talk about finding the measure of an angle here. Let's find the measure of an angle. It says the measure of angle C. How many degrees, kids?
68.
Okay. Let's talk about angle C. How many degrees is angle C there, kids?
68.
Okay, let's talk about the arc that it intercepts. What arc does it intercept? A to what?
D.
Okay, A to D. Okay, well then they jump in there and say, you know what, I want you to find the measure of angle B.
Well, it's still 68.
Why is angle B going to be 68
Because
degrees?
it also intercepts A.
Again, that intercepted angle, or I'm sorry, inscribed angle, the same as C because angle C intercepts AD, but angle B also intercepts that, doesn't it? Don't you guys see my angle B right here again? Here's angle B. Doesn't it intercept AD also? So I would say angle B must equal how many degrees, kids?
68.
And how do we know that? Well, what theorem was that called up there?
What?
What theorem was that called up there?
The inscribed angles of a circle theorem.
Inscribed. Okay, so can I just write by the above theorem? Is that okay? Why not? Let's do that. I like that. Yeah, we just talked about it. These angles intercept the same arc. Therefore, the angles must be the same. By the above theorem. Okay? Angle B is 68 degrees by the above theorem.
Walk with the Texas Rangers.
Chuck Norris.
My favorite part of being driving is this drive on the dirt.
Oh, y'all need more time with this example?
Nope.
What questions do you have so far?
Come on.
Absolutely. The door's right there if you want to go home. I'm not stopping you. Okay? I can't. By law, I can't stop you. All right. Let's talk right here, kids. Find the value above of each variable. Oh my God.
What?
Okay, let's talk right here. What do we have to find in this right here?
The value of each variable.
Okay, so really we have to solve for.
X.
Okay. Well, guys, do you agree right here? Do you agree right here?
That's the diameter.
This here is the angle I'm trying to work with, right? Furthermore, do you guys agree that that's the inscribed angle we're at?
Yes.
Do you happen to know the arc measure
Yes.
that this would happen to mark off?
Yes. 180.
This arc right here is
180.
180 degrees, isn't it?
Yes.
How do you know it's 180 degrees?
Because I'm smart.
Well, I like that answer. I'm smart. I'm not, so give me an explanation.
Y is the diameter, and so it's splitting the circle in half, so that arc is going to be half the circle, which is 180.
Very good. If I have a diameter right there, you know the intercepted arc is how many degrees? So we could set 5x. Oh my gosh. I've got to think about this, kids. If this is 180 degrees, what's that make this angle right down in here then?
90.
This would be 90 degrees. So to solve for x in this right here, we would have to set 5x equal to what? By the way, doesn't that kind of look like a right angle right there, kids?
Yeah.
Okay, what is 90 divide 5?
45.
No.
Oh my god, what?
If it was divide 2, you'd be in great shape, but it's not.
18.
X would be 18. Okay?
I think he was serious too. That's like
No.
a lot. Wait, how do you get 90?
All right, so right here, Sonny, this angle right here, when we talk about intercepting arcs with inscribed angles right here, this angle that I'm talking about is on the circle. And there's a theorem that states that any inscribed angle here is going to be half the measure of the arc it intercepts. So if this arc is 180 degrees from W to Y, which this angle is made up of right here, this angle would be half of that arc measure, which means this angle is how many degrees? So to solve for x, we have to set 5x equal to what value here? Okay. All right, which variables do we have to solve for up here, kids? Okay, this is a little more difficult. Okay. Let's talk about this. Let's get some numbers in here. All right. Let's go up to arc. Let's go up to arc DA here. Well, you know what? I'm going to back up. Let's do the 3/8 part first in red. Guys, you agree that this arc right here takes care of arc BC? Would you agree with that? Problem is, I don't know the measure of this arc. Do I?
So we should do the other one.
Okay, maybe we can do B.
No.
All right, maybe what we should do is get some arcs in here and see what happens. Let's see what happens. Let's start up here from A to D. A to D is across from which angle here? Well, I don't even have that, do I? Let's go A to C. AC right here, kids. What's angle B's measure? Okay, so...
I found this on the web for what angle B is matter. Check it out.
Nice.
Thank you, Siri. All right, 111. Couldn't I double? Doesn't this angle go right to here? So this arc right here, C to A, couldn't I figure this out? How much? 222. Okay. Ooh, doesn't 65 degrees take care from D to B? Right here. Doesn't 65 take care of D to B? Hello? 65 takes care from D to B, doesn't it? What's double 65? 130, right? Oh, quick question. Guys, hey, are you ready?
Yes.
Doesn't this arc right here, isn't that the remainder right here of 222 and 130 added together? We know what 222 and 130 added together, because this goes from D to B off this angle, doesn't it? What's 130 plus 222?
352.
Something doesn't seem right here.
352. Wait, hold up. There's no way the other one's only 8. I refuse to believe that.
I'm sorry, I've got this all wrong.
Row.
Yeah, let's get rid of that 222 part.
But the 2. Now are we sure 65?
Hey, I'm stuck. I'm going to get rid of all my ink up here, okay? Let's start over. I need new thoughts. Okay, I have a question. Doesn't angle... Guys, listen, please. Well, then move, all right? Okay. Actually, from A to C, how many degrees would this be, kids?
A to C would be 222.
There's your 222 degrees, right?
Yeah.
Okay, I have a question then. The part that I have not arced off, kids, isn't that this right here? Isn't that in red? How many degrees are on that red arc? How would you find that?
We take, yeah.
So 360 minus what? 222. Do that for me. 138, you said, Sonny?
Yeah.
Okay. Hey, quick question here. Watch what I do. Isn't this angle in red? Doesn't it subtend? I didn't want to do that. I'm sorry. Doesn't that subtend this angle right here, angle D? So wouldn't 3A be half of 138? What is half of 138?
Oh, I'm so wrong. Wow.
60 how much? So what's that make my A value, kids?
13? Oh, 23.
So A is 23. Quick question, kids. Once I know that this angle up here is 69 degrees, how many degrees are in a quadrilateral? 360, right? So if this is 69 and this is 65 and this is 111, couldn't I just add them all up and subtract that from 100 and... Hi, Jazzy. What's up, kiddo? There's one right over there, and I have the goal sheet already, so I'm going to just set them up here today while you guys are strolling in. Nothing changed for you much. Just get out of the box and run like the wind. Okay?
It's 5:30, right?
Running is at 5:30. You are correct, ma'am. I'm pumped for you guys. I can't wait to get going. I'm excited. Well, it's not going to rain. It's going to get sunny, actually. It's because Sunny came to class, and she said it was going to get sunny. This class got sunny real quick.
Nice use.
Okay. Hey, how many degrees are in a quadrilateral again, kids? Okay, so how would you find angle B?
You subtract all the numbers. You would add 69, 65, and 111.
Okay.
Subtract that number from 360.
Can I show you something real quickly? What's 111 and 69 add up to?
180.
Oh. What do we get for an answer here in B? If you take 360 minus this, this, and this, 115? I'll show you something here, kids. It's kind of magical. It happens with quadrilaterals a lot. Watch this. It's pretty cool. See my opposite angles here of 115 degrees and 65? What do they add up to? Oh, my Lord. 180. Okay. See this 111 and 69 right here? What do they add up to? What might you say about inscribed, how many sided figure? Quadrilaterals. What would you say about opposite angles that are inscribed in a circle? They add up to what? 180. 180. What's another word that we use mathematically for two numbers that add up to 180 degrees?
Supplementary.
We say opposite angles of an inscribed quadrilateral are going to have to own 180. Two big theorems right here. Two biggies. And we just discovered them. We just discovered them. Big time. Okay? Christopher Columbus got nothing on me because we just discovered these theorems. First one's called what, kids?
Inscribed right triangle theorem.
theorem.
If a right triangle is inscribed in a circle. What kind of triangle?
Right.
Then the hypotenuse must be the what?
Diameter.
Conversely, if one side of an inscribed triangle is the diameter of the circle, then the triangle is what type of a triangle?
Right.
And the angle opposite the diameter is a right angle. This is simply saying this, kids. If you ever have a circle where, I don't want dotted circles. It's not a circle if it's not solid, right? If you ever have a circle and you ever put a diameter to it like this, if you ever use those two endpoints of a diameter to form a triangle, or put your inscribed angle inside that circle using those two endpoints as your chord, this angle always, always, always will be what type of an angle? Okay, if you ever pass through the diameter, then this inscribed angle must be what? And think about it. Doesn't the diameter cut this into two semicircles? And half of a circle would have an arc measure of?
180.
Meaning that this intercepting arc of 180 degrees would be bound by an inscribed angle half that measure, which is what? Okay, then the other part of this says the following. If you have a four-sided figure inside a circle, draw your circle.
Drawing it.
Whoop!
Brianna's not
Put a four-sided figure in there.
square.
I don't care what you put in there. You could put a square in there. I'm going to make mine a little goofier.
Jonathan put it.
There's mine. It says a quadrilateral can be inscribed in a circle if and only if its opposite angles are what?
Supplementary.
If I call this A, B, C, and D, A plus C must equal how many degrees? And what's the other one?
B and D.
B plus D would equal, okay. All right. Inscribed right triangle theorem. You only have a right triangle if the hypotenuse is the what? You only have a right triangle if the hypotenuse is the diameter. Okay? And if you ever have an inscribed quadrilateral, 4 sides, then the opposite angles are supplementary or sum up to absolutely. Okay? All right, so let's check this. Oh, I got an interesting problem on the next page. Let's go. Are we on the last page yet? Here we go. I need a volunteer to read this problem here for me.
Your camera has a 90-degree field of vision, and you want to photograph the front of a statue. You stand in a location in which the front of the statue is all that appears in your camera's field of vision as shown. You want to change your location. Where else can you stand so that the front of the statue is all that appears in your camera's field of vision?
Simply put, they're saying where can I stand so that I get this whole line right here. So the whole front of the statue is what I want to see, right, kids? What they're saying is where could I stand so that I get the whole front of the statue? Well, no matter what, kids, that's just going to come from being on that circle. No matter where I move to. If I move here, let's just say I move right here. Whew, isn't this like a semicircle here, kids? It is, because what angle was formed from end to end at that point? Yeah, so what angle would be formed here? Has to be 90 degrees. So if you move anywhere around that arc, you would get this whole front in there. Does that make sense? Okay? That's all that's going on here, guys. You're simply using the front as your diameter. You're saying, where can I move so I can get that whole front with my camera? Well, just move. So your angle is 90 degrees to that, and it intercepts those 2 points. That's all they're asking you to do. So anywhere on the blue line is your answer here. I'm just going to say anywhere on the what? There you go. See? We're lucky. Noah's got our back. We're on the ark now.
No.
Not good?
No.
Okay. Yeah, you can stand anywhere on the ark there, kids. Okay. All right, so here's what I'd like to do. Let's do some progress checking. Then I'm going to have you guys check yourselves with your peers. These progress checks, let's see if we can figure these out. They don't show up very well for me. Anybody know what x is?
90.
Why is x 90?
Is half of 180.
X has to be 90. Give me a show of hands on y then. How would you find y?
Well, 180.
180 minus 90 minus, okay, because it's a triangle in here now. So what's that make y? 50? Okay. Hey, you guys on your own. Do 5, 6, and 7 there, okay? 5, 6, and 7, we'll talk about it, and then I'm going to leave that peer evaluation for you guys to do before we come to class tomorrow. We'll talk about that, have a little bit of time to work on this stuff. Tell me when you have answers for 5, 6, and 7. If you have questions, raise your hand. I'll come around and help it out, all right? Is this an angle up here, guys?
Yeah.
What's this say? I got no sheet here. my key goes off to find my phone, or vice versa. If I lose my keys, I can use my phone to find my keys. You know what's really bad? When you lose both of them. Hey, what's y have to be, kids?
Y is 90.
Y's got to be 90 again. You know this. How'd you find x?
Wait, how did I find X?
Yeah.
I took
If this is 90,
35.
okay, so 2x would equal what? 2x would equal 35 here, right?
Yeah.
Because if this is 90 and this is 55, whatever the difference, yep, x has got to be. Very good. Okay. All right. Guys, we just talked about this. What kind of figure do you have here? What has to be true about opposite angles? Okay, so let's talk about x. X is opposite how many degrees?
98.
Yep, it's opposite of 82, so 82 plus x has got to add up to what? Got to add up to 180, right? Okay, this is 65, so y's got to be close. Is that 65 or 68? Is it?
Yeah. So 112.
Okay, so y would be 112 here, because it's a four-sided figure. Okay. Ooh. Is that an x up here? This is 10x, and this is what?
8x.
Okay, so opposite 10x plus 8x has to add up to what? 180. So wouldn't I be able to say 18? X equals 180. So what's that make the x value? Okay, we've got that. Is that a C that they're using, kids?
That is a C.
Four-sided figure inscribed here. C plus 2C would make what?
3C.
So wouldn't 3C minus 6 have to add up to what here, kids? Okay, so how much are you adding? Careful.
What?
Not 174. We got to add 6, don't we?
Ah, 186.
There you go. What do you guys get for C then? 62. Okay. Your job before you come to class tomorrow is to have the peer evaluation done down here. Okay, we'll talk about that first thing. I did send out a new online. 10.4 is out, so make sure you get into that, get started. Won't be due until Thursday. Really, you pretty much multiply by 2 or divide by 2. Or if you understand that one side of a triangle is the diameter, then the inscribed angle must be 90 degrees. Likewise, if you have a four-sided figure, then